3.1 Algebraic Expressions. This is part 2. We're going to start with example 4, and we're going to be talking about evaluating an expression that has two variables. Remember, variables are going to be letters that represent an unknown number. And the first one we're going to take a look at is a divided by b. If this is our original expression, a divided by b, remember that we can't actually solve or evaluate expressions unless we know what the variables represent. And even though eventually you'll be able to solve them on your own, right now they are going to tell us what each variable represents. So remember, we just fill in what each of those is representing. A equals 16. And b equals 2/3, so we're going to rewrite it, and then we're going to solve using all of that stuff we know about dividing fractions. Remember that when we divide fractions, we have keep, change, flip. So 16 is going to be the keep, and we're going to change that division to multiplication, and then we're also going to flip that fraction, 2/3, to its reciprocal, 3/2. At this time, it's also okay if you want to put that 16 over a 1 so that you're dealing with two fractions. And then we're going to try to cross simplify, because remember, this is something that a lot of us still need some practice on. So we look at the 16 and a 2, and we notice that they're both even, so we could divide them both by 2 if we wanted to. Divide that and leaves you with 1. 16 divided by 2 leaves you with 8. And then we have to look the other way. Remember, look both ways before we cross. And 1 is as low as it can go, so we're not going to be able to do any simplifying there. And I'm running out of space here, so I'm going to do my rewrite to the side. And 8 over 1 is what we have when we did the simplifying on this fraction. And then times 3 over 1 when we simplify this other fraction. And again, please don't skip this rewrite step. I think a lot of you on your Chapter 2 test did skip that, and you couldn't read your own writing after all the cross-simplifying, and you made silly mistakes. So really don't skip that rewrite step. And then 8 times 3 is 24 over 1, which we can't leave as an improper fraction, so our final answer would be 24. Example 5 is evaluating expressions with two operations this time. So when you have more than one operation, of course, you're going to have to follow the order of operations, or remember your PEMDAS rules. So part A says to evaluate 3x minus 14, and at first you only see this as the operation symbol, so you only see that subtraction sign. But remember that 3x, when you put the 3 and the variable right next to each other, means multiply. So that's technically a multiplication piece. And they did have to tell us that x equals 5 in this case. So we're going to start by rewriting our entire expression, 3x minus 14. And then the next thing we're going to do is fill in what we think the variable equals. And it says 5. And remember to put parentheses or something that indicates multiplication in between your 3 and a 5, otherwise it ends up just looking like 35, and you don't want that. You want it to look like 3 times 5. If you choose not to do the parentheses, you can put a dot. You might start to notice, and we'll talk about this, we tend not to use the x as multiplication anymore, and if you look up here you can see why, because now that we're using variables and the letter x might be in there, it could get a little confusing. So we start to use the parentheses more for multiplication, or the dot for multiplication as well. And then this is just going to stay minus 14. And remember, order of operations says we have to do any multiplying or dividing before we do any adding or subtracting. So we're going to do 3 times 5, which is 15, and then minus 14. And then there's only one operation left, which is the subtraction. So you go ahead and do 15 minus 14, which equals 1. And just to finish this off, these are the basic steps that we used, and I do want you to write them down for this first time so that you can come back to the steps as you're working on practice problems later, and make sure that you're following this exact same setup every time. So step 1, we always write the original expression, and this time it was 3x minus 14. Step 2, we substitute the given value. In this case, they told us that x equals 5 for that variable, so we rewrite the expression, but we substitute the x for the 5. and then leave the minus 14. And then finally, we evaluate using any of the correct order of operations. So first we had to do multiplication, then we have to do subtraction. As the expressions get longer, there may be more operations that you have to deal with, but for right now, this will cover it all if you just say evaluate using all of the correct order of operations. And for letter B, again, we're still dealing with two operations here. And again, just like that last one, it looks like we only have addition. But when you have z to the second power or z squared, that's basically a multiplication type question because exponents mean to multiply. So when we have z squared plus 8 and 5/10, we know that they want us to put z equals 2 in there. So we're going to go ahead and rewrite 2 to the second power, and then plus the 8 and 5/10, or 8.5. And remember, 2 to the second power is the same thing as 2 times 2 plus 8.5, and then 2 times 2 is 4 plus 8.5. And again, now that we've finished chapter 2 and we're just supposed to be able to use our fraction and decimal work correctly, you would have to remember that if you were doing side math on this one, you'd have to make sure that you line up that 4 with the 8 because that's the whole number, and don't line it up with the 5 because that's in the tens place, and when we add, we've got to add them up according to place value. So if you did that, you could stick the decimal 0 in there and then add, and that would give us the 12.5. So our final answer would be 12.5. And again, whoops, I just covered up my decimal. There you go. Make sure you remember to add and do all of your operations correctly, especially when you're doing fractions and decimals now. For example 6, we're going to take a look at a real-life application of how you might use evaluating expressions. And the question says, you're saving money to buy a skateboard. You begin with $45 and you save $3 each week. So the expression 45 plus 3 times W, and in this case they picked W to represent week. Remember, we said variables can be technically any letter of the alphabet, but sometimes we pick one that makes sense. So they picked W for week. So 45 was that original amount they started with, and then it's $3 each week after that. And it says that gives you the amount of money that you save after a certain number of weeks. And we can look at weeks being after the first week, after the 10th week. We can change this expression to see how much money we have after a different number of weeks. So for letter A, it says how much will you have after 4 weeks, after 10 weeks, and after 20 weeks. So one way to do that is to set up a little bit of a table or a chart. So your table might look like this, and you would think about the number of weeks that you're trying to figure out. So they wanted to know how much money you'd have to have after 4 weeks, after 10 weeks, and after 20 weeks. And each time we use that same expression, 45 plus 3 times W, but each time you'll notice we stick in a different value for W. So the first time we want to know after 4 weeks, we put a 4 in there, and then we go ahead and we evaluate that, 45 plus 12, because 3 times 4 is 12, equals $57. Whoops, sorry about that. That one got away from me. And then that means you would have $57 after 4 weeks. And then the next one down they were asking about was after 10 weeks. So again, then you're looking at 45 plus 3 times W, but you put the 10 in there to see how much money you have after 10 weeks. And you evaluate again, 45 plus 30, because 3 times 10 is 30, would equal $75, so that would be after 10 weeks. And then for after 20 weeks, 45 plus 3 times 20, and 3 times 20 is 60, so 45 plus 60 would be equal to $105. Now, that's just evaluating, and that was all for question A right here. Question B says, after 20 weeks, can you buy the skateboard? And so you would have to go into your original question, and you would have to notice how long you've been saving, but then you'd have to go over here and you'd have to see how much that skateboard costs, and it says it's on sale for $125. So after 20 weeks, we only have $105. So for the answer to letter B, we would have to say after 20 weeks, you have $105 saved. So no, you couldn't buy the skateboard, or you don't have enough to pay the $125. So you could just finish writing that one out.